Inside every single gadget we use, there's this hidden world, a silent, high-speed universe that we almost never get to see. Well, today, we're prying open that black box. We're going to deconstruct one of its most vital components, the flash memory chip.
I mean, really think about it for a second. That moment you hit the power button on your smart TV or your Wi-Fi router, anything really, there's this almost magical, instantaneous leap from off to on, from a dead screen to a fully working device. So, what's the secret sauce behind that?
Well, it's all thanks to this incredibly intense, split-second race against time, and it's being run by a component that's probably smaller than your fingernail. This tiny, unsung hero is what loads all the essential software that literally brings your device to life.
And that's exactly what we're going to do in this explainer. We're going to pop the hood on one of these heroes. We're diving deep into the technical data sheet for the PN26Q01A, a 1 gigabit SPI NAND Flash memory chip, to really see what makes it tick.
So before we can really understand the chip, it kind of makes sense to know who's behind it, right? So let's meet the manufacturer, XTX Technology.
So XTX Technology is a highly specialized design company. Their whole world revolves around one thing: creating super high-performance, super reliable flash memory. You can basically think of them as the master architects designing these tiny digital libraries that our modern world absolutely depends on.
All right, we've met the creators. Now let's zoom in and get to the main event, the PN26Q01A memory chip itself.
So what in the world is SPI NAND Flash? Let's break that down. First, the NAND Flash part just means it's non-volatile memory. In simple terms, it holds on to its data even when you unplug it, which is, absolutely essential for storing startup software. Then there's the SPI part. That stands for Serial Peripheral Interface. Just think of it like a direct private hotline between the memory chip and the brain of the device, the processor. It uses very few physical connections, which saves a ton of space and makes everything less complicated.
So here we're looking at a blueprint of the chip's internal layout. As you can see, it's neatly organized into 1024 blocks. All told, this gives us a total of 1 gigabit, which works out to about 128 megabytes of space. And yeah, I know, 128 megs might not sound like a ton compared to your smartphone, but trust me, for its specific job of holding boot code, it's the absolute perfect size.
Okay, now for the really cool part. We're going to decode the key features of this chip, and I like to think of them as its superpowers. This is where we see how those technical specs on the datasheet translate into actual, real-world performance that you can feel.
Superpower number 1. Pure, unadulterated speed. When we're talking about boot up times and how snappy a user interface feels, speed is absolutely everything. A tiny fraction of a second is the difference between a device feeling instant and feeling, well, frustratingly slow.
And wow, does this chip deliver? It clocks in at a maximum data transfer rate of 352 megabits per second. I mean, for a component this small, that is just blazing fast. It's the secret ingredient behind that instant-on feeling we all love.
And that's the key, right? This isn't just a number on a spec sheet. That speed directly translates into a better experience for you. It's why your router connects in a snap after you restart it, or why the settings menu on your TV just appears with no lag.
So you might be wondering, how does it pull off that kind of speed? Well, it's through a clever trick called Quad SPI. Just look at this table. In its normal mode, pins like WP hash have one job, write protect. But when the chip needs to go fast, it enters quad mode and cleverly repurposes those pins into extra data lanes. It's like taking a regular 2-lane road and, poof, turning it into a 4-lane superhighway, letting way more data flow at once.
Okay, so speed is awesome, but it's pretty useless if the data is all wrong. And that brings us to superpower number 2, rock-solid reliability. Because if the boot up data gets corrupted, your device is basically a paperweight.
To prevent that, this chip has a built-in defense system called Error Correction Code, or ECC. Honestly, the best way to picture this is like having a built-in automatic spell checker for your data. As information gets read from the chip, the ECC engine is constantly scanning for tiny errors, individual bits that might have flipped, and it fixes them on the fly. It makes sure the data that reaches the processor is always perfect.
And this isn't just about day-to-day accuracy. We're talking about the long haul. The datasheet actually guarantees data retention for a full 10 years. That means the crucial software on this chip is going to stay intact and ready to go for at least a decade, giving the device it's in a nice, long, stable life.
So we've got speed, we've got reliability. But in today's connected world, there's another piece of the puzzle that's absolutely critical: security. This chip was designed from the ground up with multiple layers of protection to keep its data safe.
And we're not just talking about one simple lock either. This thing has a whole security arsenal built right in. We've got things like software write protection, a unique serial number for every single chip that comes off the line, and the ability to lock individual memory blocks so they can't be changed. But the coolest feature by far is a special little area called the OTP region.
This OTP, or one-time programmable region, is basically the chip's maximum security vault. Think of it like a time capsule. Once data is written here, it is set in stone. It can never, ever be changed or erased. This makes it the absolute perfect spot to store the most sensitive stuff, like encryption keys or a device's permanent, unforgeable ID.
All right, so we've got these three amazing superpowers: incredible speed, bulletproof reliability, and Fort Knox-level security. So where does a chip like this actually end up? Where does it live out in the real world?
The short answer? Pretty much everywhere you look. That lightning-fast speed is perfect for Wi-Fi routers and network gear that need to get up and running fast. Its long-term reliability is crucial for things like smart TVs and set-top boxes. And that combination of low power and tight security makes it an obvious choice for all kinds of smart home hubs, IoT sensors, and wearable tech.
Okay, so we've followed the journey from the design lab all the way to the devices in our homes, but hang on. There's a super important step in the middle we haven't talked about yet. How does this little component get from the factory into the hands of the engineers who are designing the next cool thing?
And that's where a distributor like eBetter Company Limited comes in. They play this absolutely essential role in the supply chain. They're the ones who bridge the gap between the chip makers, like XTT, and the product makers, making sure engineers have access to these incredible components and fueling the innovation that creates all the tech we use every day. And that really brings our deep dive to a close. We've seen how this tiny but mighty engine works, but it also gives us a glimpse into what's next. The evolution of memory chips like the PN26Q01A is just relentless. It really gets you thinking, right? As these components get even smaller, even faster, and even more secure, what kind of new devices, what new possibilities are they going to unlock? What does the future look like when you can pack this much intelligence into such a tiny space? Something to think about. Thanks for joining me on this explainer.